Hello class, welcome to this video on basically we're covering segmented bar charts and scatterplots. So essentially the lessons 3.1 and 3.2. So we're going to actually do the graphs and make sure you get some practice in doing these graphs so you can get a feel for how they work and how to interpret them and so on. Okay, so for each of these exercises, decide whether you want to use a segmented bar chart or a scatterplot. Construct the chart that you choose. Remember that the explanatory variable goes on the x-axis for either chart. If you're constructing a segmented bar chart, show your calculations for the percents that were used to make it. So the table presents data on the elevation in feet and average January temperature in degrees Fahrenheit for 10 cities and towns in Colorado. Data is provided below. So you look at this data. You have elevation in feet. So these are numbers, elevation. And then you have average January temperature. So these two sets of data, they're numerically based, right? They're numbers, and so these are quantitative, right? So this variable is quantitative. This variable is most definitely quantitative, or both of them. So therefore, the chart that we're going to use is the scatterplot. Okay, so the scatterplot is used to compare two quantitative variables to each other. So we need to construct a scatterplot. All right, so then we're going to have an x and a y-axis. Which one is the explanatory variable? So which one would help explain the other? So if you look at this, it seems that, so what we would think is, as the elevation increases, that might cause the temperature to decrease. You know, generally in high elevation areas, the temperatures tend to be lower, right? Or they may be higher. Like, so most of the time we know that if as you go higher up, the temperatures tend to be lower, right? So in a mountain, there tends to be snow. There tends to be cooler regions, right? As opposed to down at sea level. So we know that elevation could impact the average temperature. And so we're thinking that the elevation is the explanatory variable. So this might be the explanatory variable that could help explain changes in the average temperature. So this would be the response variable. And remember that in a scatterplot, the response variable is the y, the explanatory variable is the x. So we know that elevation is going to go on the x-axis. We can ignore the city. This is just extra information. This tells us which city it comes from, but we don't really need to know which city it comes from to draw the scatterplot. We just need the data. Okay, so since the elevation is pretty high here, let's see, let's do elevation. These are going to be pretty large numbers. So let's start at around, the smallest number is 4,500. So let's start at around 4,000 and then go all the way. So let's do the scale from 4,000 to about, the highest here is 9,000, right? So let's do for 4,000 to 10,000. And so we'll go by thousands, or we'll go by 500s, okay? And then for the January temperature, that goes on the y-axis. We can, that's fine. We can start at 0 and then go by 5s until we get to like 35 or something like that. Okay. So that should be able to work for us. But you can go by whatever scale you like. So you don't have to go 0 to 35. You can go 0 to 40 and go by 2s, anything you want. So let's go ahead and make the scatter plot. So we're going to need plenty of room on the x-axis and a little bit on the y. So on the y-axis, let's go to the 35, and we want to go by 5s, right? So, or at least that's what I said. Okay, so let's see, we're going by 500s. I said 500 is not 1,000, right? So let's see, 4,500. And we'll finish off with 10,000 towards the end. Okay, so we said that this is the elevation. And this was the average January temperature in degrees Fahrenheit. Okay, so we're going to go ahead and plot each of these knowing that this is going to be X, this is going to be Y. So these are my coordinates right here. So about 5,527. About 5,231. So it doesn't have to be exact here. It has to be just, it could be estimate. 6,429. 5,029. 6,621. 8,218. 7, about a little over 7,100, so almost 7,200. 25. 5,426. 4,629. And finally, 9,000, 9,000, a little over 9,016. Okay, so this is my scatter plot. So as we can see that there does seem to be some kind of relationship, some kind of negative relationship between elevation and the average temperature and the elevation. And it seems to be a pretty decent relationship. Like, there are no obvious outliers by looking at that. So it seems to be a pretty decent relationship between elevation and then the temperature. Okay, so that's our scatter plot. So the Pew Research Center asked a random sample of 2024 adult cell phone owners from the United States, their age, and which type of cell phone they own: iPhone, Android, or other, including non-smartphones. The two-way tables provided below. So notice that our variables here, the type of cell phone is categorical. Type of cell phone, iPhone, Android, other. No, this is not a numerical base. This is a category, right? Age. Now, age would normally be a quantitative variable. However, the way that they broke it down here, they broke it into categories. You're in the ages 18 to 34. So they broke it into young versus middle age versus, older, right? So they broke it into categories between two numbers. So are you in the young category, 18 to 34? Are you in the middle 35 to 54, or are you older, 55 plus? So these are categories. And so the way they broke it down, this would be categorical in this example. Okay, so definitely we're comparing categorical to categorical, and therefore we're going to use, the ideal thing to use is a segmented bar chart. Okay, so we got our segmented bar chart. So now we know what we're going to use that. So which one is my explanatory variable? Well, if you think about it, it seems to me that there might be a relationship between the age and the type of cell phone used. Maybe older people tend to use less smartphones, right? So you have iPhone, which is a smartphone, and Android is a smartphone. Most of them are. And other could be like flip phones, things that are not considered to be smartphones, or maybe like other types of phones like Windows phones or something like that. You know, that those are smartphones too, technically. But maybe I would think that older people might use like flip phones, or things that are not as techy, because maybe they're older. Who knows? Maybe the young folks tend to have more iPhones. Maybe middle aged tend to have more Androids. I don't know. We're trying to see if age has a relationship. I think that age could impact the type of cell phone usage, and therefore age is considered to be the explanatory variable. Okay, so in this case, age is explanatory. Which means that goes on the x-axis. So age is going to go on our x-axis, and then the percent is going to go on the y-axis. When you do a segmented chart, you have to have percent on the y, and then the explanatory on the x. Okay, so that means my categories, these are my categories that I'm going to use. And so these are going to belong to my key. So whatever is not the explanatory is going to go on the category, on the key. So we need to make a key for iPhone, Android, and other. And so we're going to say that a completely blank bar will represent iPhone. A complicated texture, maybe like a dotted texture, would represent an Android. And then let's say a filled in texture would represent other. Okay, so you get to decide that, but this is my key for my categories. And so now I'm going to make my segmented bar chart. But before I do that, I need to calculate my percentages. So let's do that off to the side here. So for my percentages, we know that we need to calculate it for young, middle age, and older. Okay, so 18 to 34, 35 to 54, and 55 plus. So of these people in the 18 to 34 category, how many own or use iPhones? What percent of people that are in that age group use iPhones? Well, let's look at it. You have a total of 517 people in that category, 169 of which use iPhones. Okay, so that means that 169 out of a total of 517 people in that group times 100 will give you the percent of iPhone users in that age group. So we have, this is about 33%. We're just going to round it to the nearest percent. And then how many people in the age group use Androids? What percent? So we have 214 people use Androids that are out of 517. Okay, so 214 out of 517. So that's about 41%. And so then other, we're going to guesstimate other. And remember, these percentages had to add up to 100, right? So 33 plus 41 is 74. So this is 74%. So 100 minus these other percents will give us the rest of it. So 100 minus 74, that's 26%. So we'll kind of guesstimate that it's 26% based off of the other 2%. All right, you could do that. 35 to 54. So then for the 35 to 54 age group, how many of them use iPhones? So this is the 35 to 54 age group, 637. 171 use iPhones. So that's going to be about roughly 27%. This one, how many use Androids? 189 times 100, of course, to convert it to a percent. So that's about 30%. And then lastly, you could do 100 minus 27 plus 30. 27 plus 30 is 57, and then 100 minus 57 is 43. Of course, you don't have to do that. You can use the fraction and times it by 100, but this is easier for me to do. 55 plus, so 870 people, 127 use iPhones. So that's about 15%. And then 100 use Androids. Definitely less use Androids. Got 11%, around there. And so we got 100 minus 15 plus 11. 15 plus 11 is 26. 100 minus 26, about 74%. So, wow, that looks pretty interesting. So 74% of older folk use other types of phones. Probably going to be the flip phones, that kind of stuff. And only 26% use these smartphones, iPhones and Androids. Very low percentage compared to really young people, 33 and 41. That's 74% of the people in this age group use these smartphones. Only 26%, so about a quarter, use other types of phones. So that's pretty interesting. There's definitely some kind of interesting associations going on here. So there's an association between the age group and the type of phone that they use. So we're going to be using these percentages in our graph. So let's go ahead and get started. So we have, let's go by tens all the way to 100%. Okay, so we have our cell phone type, so on our x-axis, and we have our percent on the y-axis. Okay, so we're ready to graph this. So we know that based off of the data that we calculated, 33% of people in 18 to 34 use iPhones, and iPhones we're going to use as a blank. It's not filled in rectangle. So we'll do that first. 33% is around there. Okay, so that's our iPhone users. And then for Androids, 41%, 18 to 34. So this is a stacked plot. So 41 plus 33 is 74. So it's going to stack up to the 74 mark. 74 is around here. Okay, and this is my Android, so I'm gonna that's a polka dot, I guess you can say. And then finally, the other one has to add up to 100% in total, so you know you're just gonna go to the 100. That one was filled in. All right, so now let's go ahead and do Android, or oh, I'm sorry guys, this is not the cell phone type, I apologize. I just said the x-axis is going to be age, right? So I used a cell phone type. This should be age, not cell phone type. Apologize for that. 18 to 34. So hopefully those of you that were paying attention to what we were saying earlier are probably confused. So I'm going to go ahead and fix that. Sorry about that. 35 to 54. Age group. And then 55 plus. So this is the age group. All right, that's exactly what I wrote here. I just didn't do it. All right, so now 35 to 54. How many of those use iPhones? 27%, and then 30 for Androids. So 27% for these guys here, and then 30 for Android. So 30 plus 27 is 57. So this will stack up to the 57. So these are the Androids. Right, and then it has to add up to 100%. Wow, so it looks like a good portion of middle age use the other types of phones too, huh? It looks like it's more. In fact, it is substantially more. It's 43%. And then 15, 11, and then 74. So 15 for the first one. $11 plus 15 is 26, so this will stack up to the 26. And this has to add up to 100. So a substantial portion. Look at that, 76%. That age group. They'd rather not be bothered with smartphones. So it looks like they really, really prefer the standard phones, the traditional flip phones, maybe, is what I'm thinking. So there's definitely an association between the age group and the cell phone type based off of this segmented bar chart. All right, that's going to do it for the homework, guys. I went ahead and took my time on it to make sure that I kind of walked through my thought process and how to do it. I hope you found this useful and you learned something. And as usual, I'll see you in the next one.